Hello, ladies and gentlemen. Welcome. Thank you so much for stopping by. Today, we're going to be coding the stack data structure in Java. So I know a lot of you guys are fresh out of school. Maybe you're still going through school, trying to learn how to become a programmer. Maybe it's a hobby that you have on the side. But one important crucible of software development is data structures. It's very important to know about these different data structures, which is how the computer can store data, reference data, and pass data around in an efficient way. So it's very important to learn these basic concepts and to refamiliarize yourself occasionally just to make sure that you stay up to date and still knowledgeable about these common data structures. So once again, today we're going to be talking about the stack. The stack data structure is, imagine that you're laying down plates. You lay one plate down, you grab another plate, that plate goes on top of that one, you grab another plate, now you have three plates. You're creating a stack. The very last plate that you pulled is going to be on the top of the stack. So that's last in, first out. You'll sometimes hear that referenced as LIFO. It's the opposite of first in, first out, FIFO, which is occasionally how people reference a queue. But just imagine a stack of anything, a stack of cards, a stack of dollar bills, which is never a bad problem to have. But that's the concept of the stack. And one main place a stack is going to show up is in a stack trace. It's kind of obvious, stack is in the name. So if you've ever been doing any debugging or trying to figure out why your program's not working, you'll get a stack trace. And that is basically showing you each call to a function. So every time a function gets called, it gets put onto the stack with the local variables and the scope that is necessary for it to come back to that particular function. So a lot of times in a stack trace, you'll have one method on top of another on top of another, and you need to sort of know the concept of a stack to know, okay, how do I find the root cause of this issue? And a lot of time where the issue actually started will be towards the bottom of the stack because it'll be printed from top to bottom. So let's go ahead and get started. We'll dive right in here and start coding this stack up. So I've basically just created a generic Maven project using IntelliJ. It's the IDE I like to use. You might be using Eclipse, you might be using something else. I do recommend IntelliJ. It has fantastic features, very easy to use, and very user-friendly. So give it a shot. You know, they have a community edition that you can try. I think you'll really enjoy that. So what we're going to do is we're going to create a Java class, and we're just going to name it stack. Okay? And what we want to do is we want to make this stack generic so that we can specify any object that we want to put into this stack. So it could be an integer, it could be a string, it could be a node class. When we specify T here, we're saying, okay, whoever instantiates this class, they can tell us which type they want to use. So we're going to need a couple of variables here. We want to have the capacity, so we want to know how many objects can this stack hold. We want to have the actual array. We'll call that S. And we want to have the index of the top value, which we'll call top index. We're going to initialize this to -1. It's very important to initialize this to -1 because that's going to represent an empty stack. Okay, so that's important that we have that as well. And these should be the three private members that we need to get started to actually code this. So the interface of a stack, you've got to have your top, you've got to have your pop method, and then you also want to have your push method. Push will allow you to put new objects onto the stack. Top will return the top object from the stack for you, and pop will remove the top object from the stack. So we're implementing this in its most basic form today with just an array, and we're going to assume that the array cannot grow. And what we'll do is we'll just return nulls when things are empty, and we'll throw maybe we'll throw exceptions when we need to if we've reached capacity. So the first method we're going to implement is going to be the constructor, and we're going to go ahead and pass in the capacity variable. So when you instantiate this, you should kind of have an idea of how large it needs to be. So we'll let the user pass in the capacity. And we'll go ahead and set a default value of 10. And I'll provide an empty constructor as well, so that if you want the default, that's fine. Otherwise, you can overload it and pass in the capacity there. So now that we have the capacity, we should be able to instantiate the array. So we want S to equal new object array of capacity. And this syntax might look a little strange to you. I highly recommend you do some research on generics and arrays and how that sort of works, but we basically need to tell this we can instantiate a new array of type T. So for instance, if I were going to say new T capacity, which you think would work since S is an array of type T, well, it says type parameter T cannot be instantiated directly. That means we can't actually use this, and it has to do with runtime, what the compiler knows, and how the system is going to behave at runtime. It doesn't know what T is, so it has a lot of trouble there. So we're basically specifying it as a new object, but we're going to cast it to T because we know it's going to be T based on our members and methods. So there we go with our constructor. Let's go ahead and implement our size method. And for size, we're just going to return top index plus 1. So when we do size for the first call, it'll be 0 since we instantiate top index to -1. We're going to do public boolean is empty, which will say if top index equals -1, return true, else return false. So there's our isEmpty method. This will tell us if our stack is empty. If there's nothing in it, our top index should be -1. Otherwise, it will hold a value. So let's go ahead and let's push something on there. We'll do our public T push. Actually, let's make push void. We really don't want anything returned there. So we're going to push in an object of type T, and we're going to know this has to be equal to the T that we instantiated the stack with. So that'll sort of keep our types nice and consistent. First, we want to check if size equals capacity. This means we've reached capacity. We can no longer push anything else. I'm just going to throw an illegal state exception. This is a generic Java exception. You can write a custom exception here if you want to throw it. Stack exception, stack full exception, something like that you could create, and just extend the basic Java exception. So a runtime exception you could extend if you want to do that. But I'm just going to throw the illegal state exception here. Okay, so we've thrown the exception. If stack is not full, what we're going to do is we're going to set T. We're going to set our top index equal to top index plus 1. So we're going to increment our top index, and we're going to set S at top index equal to object. So we basically increased our array by 1, the top index, and we're going to put the object that was passed in into that slot. So that should be our push. Now for our top, this should return the top object of the stack. What we want to check first is if it's empty, I'm going to return null. I'm not going to throw an exception here. I'm just going to return a null object. Else, I'm going to return S at top index. Okay, so that should give us our top object on the stack. Now let's do our pop. This is where we're going to pop the very top object off the stack. So if it's empty, once again, I'm just going to return null. Else, what we're going to do here is say top index equals top index minus 1. And we also want to capture the return object at top index before we move the top index. So we've got our return object. This is going to be the very top one. We're going to return this. And now we've decremented our top index. So we've gone down one. That's great. Now all we want to do is return that return object. There's our pop method. Okay. So those are the three main methods, push, top, and pop, that we need for a stack. We have our helper methods here, size and is empty. And we also have our constructor method. So in the one without the capacity, we're just going to instantiate it with the default capacity. Okay, so now let's go ahead and PSVM is a short key that you can use to create the entire main method here in IntelliJ. We're going to create a new stack, and what I want to create is a stack of integers. We'll call this integer stack. And I'm going to give this a capacity of 5. So let's just test our code here. We want to push a couple integers. We'll push 5 on. Then we'll push 2 on. So the top value now should be 2. Sout is once again another hotkey you can use to do system.out.println in IntelliJ. Integer stack dot top. So what I want to do here is I want to print the very top element. It's not going to take it off, it's just going to tell us what it is. So let me run this code. And what we should see is the value 2 printed. Let's give that a moment to compile. Couple of warnings there, and as you can see over here we have 2 printed, so that's working. So let's go ahead and let's pop we want to pop off that 2, and we should see, if we run it again, we should see 2 get printed first, and then we should see 5 get printed after that. Great. So let's do one more pop, and let's print the top. Now the stack is empty at this point, so we should expect a null to be printed there because it's empty. So great, we know that it's empty. So that's just the generic, real quick, quick and dirty array implementation of a stack. Now, obviously, it can be improved a lot by increasing the capacity instead of throwing exceptions. And also, you can use a linked list to implement a stack, which is a bit more efficient as well. But just wanted to give you guys a quick refresher on what a stack implementation might look like in Java, how you can quickly develop one of those and sort of play around and test it on your own. That's the best thing you can do to learn, is just get in here, start coding some stuff, see where the errors are, make mistakes, and you'll learn from there. So thanks again. Do visit MindfulBit.com if you want to follow any blog posts that I make. I also offer a coaching service. I love to sort of talk to people who are fresh in their professional career and are sort of looking to develop soft skills and necessary communication techniques that they can use to really excel at their job. Once again, thanks guys, and I'll see you on the next video. Bye-bye.